Hello everybody, this is Brianne Pernick. We are now going to start working on Chapter 1, Lesson 4 from Robert Morris University, Math 0900. By the end of this lesson, we are going to be able to write numbers in exponential form as well as evaluate expressions that contain exponents. Please make sure that before or after this lesson you are familiar with these vocabulary words and that you do know what they mean. We are going to start by writing numbers in exponential form. When we are dealing with numbers that contain exponents in them, they can be written in three basic forms. We have what is called standard form, exponential form, and expanded form. Note, I'd like you to know that your text refers to expanded form as long notation. So please be able to use those two terms interchangeably, but I will refer to the third form as expanded form, as that is my preference. Now, exponents are used as an abbreviated way to show repeated multiplication. For example, I have shown at the bottom of this page the exponential problem 4 to the third power. When we say that it is shown used to show repeated multiplication, what I mean by that is that we have 4 times 4 times 4. Now, you may think to yourself, why can't I just do 4 times 4 times 4? 4 times 4 is 16, 16 times 4 is 64. Why can't I just use that math? Whenever the problem is small, sure, we can do it that way. But if the problem is very large, like 4 to the 95th power, nobody wants to have to sit there and multiply 4 by itself 95 times. That is cumbersome. It's going to take you a long time. It's going to leave room for a ton of error, and it probably would make you a little bit hateful if you had to sit there and do all of that math. I know that I would. So we have exponents, an exponential form, and rules that allow us to work with numbers that are in exponential form, to combine them, to simplify them, to reduce them, to make our life easier when working with these types of numbers. So let's look at the basic components that make up a number when it's written in both expanded and exponential form. First of all, the larger number, the 4 in this example, is called the base of the problem. The smaller number, which is the 3, is referred to as the exponent. Please make sure that you know what those words mean so that if we're referring to the base, you know which number I'm talking about, and if we're referring to the exponent, you know what we're talking about there as well. Now, you will be expected to be able to write numbers in all 3 of the exponential forms, quote. So let's make sure that you understand what each form is. Now, the first form that we have here, the 2 times 2 times 2 times 2 times 2 times 2 times 2. This form is the expanded form. This is the form that your text also refers to as long notation. The reason that we call it expanded form is because we have taken 2 to the 6th power and expanded out that repeated multiplication to show that the base of 2 is being multiplied by itself 6 times. That's what's happening with a base and an exponent. The middle form of the number is the exponential form. That is the form when it is written as the base and the exponent. And then lastly, when you evaluate that exponent and do the math, 2 to the 6th power, or 2 multiplied by itself 6 times, and get the answer of 64, that is what's known as standard form. So please make sure that you know what each of those mean. Now, we're now going to practice writing numbers in exponential form. Our first example is 5 times 5. Whenever we have 5 multiplied by itself twice, we can write that as 5 to the 2nd power, or 5 squared. Letter B, we have negative 8 being multiplied by itself 1, 2, 3, 4, 5 times. Now, it is very important that when you have a negative base, you have to make sure that you put that negative base in parentheses so that you or your calculator or your viewer knows that it is the negative 8 that is the base, because this is not the same thing as that. They mean something completely different. Okay? So I do need you guys to make sure that if your base is negative, you are using parentheses. Letter C, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 negative ones. That means that our base is negative 1, so we are going to put that in parentheses, and we have negative 1 to the 10th power. For letter D, we have 20 to the 3rd power, which is 20 cubed. For letter E, we have A cubed. And for letter F, we have 1, 2, 3, 4, 5, 6 m's, so we have m to the 6th power. Now, you may have heard me using some different terminology there than just saying 2 to the 2nd power, 3 to the 3rd power, etc. When we have a base that has an exponent of 2, you should say that the 2 is squared, or the base is squared, excuse me. When your exponent is 3, you should use the vocabulary word of cubed. Your base is cubed. Okay? And then if the exponent is anything greater than 3, then you would just say it's raised to the exponentith power, 10th power, 6th power, 5th power, 12th power, whatever it may be. The only ones that have special vocabulary words are 2 and 3, and we say squared and cubed respectively. Now, when we are evaluating your exponents, you should know how to punch these into your calculator. I do not at any point in time expect you to evaluate exponents in memory. So depending on what type of calculator you have, you do need to know how to do an exponent on your calculator. If you are using a TI 83, you will simply do 3 caret 4 and press enter. If you are using a TI 30, you will also have the caret button on there, so you will press your 3 caret 4. Some calculators have a button that says X to the Y. So you would put in your 3, press your X to the Y button, and then press in your 4, and that will evaluate that for you. So when you do 3 to the 4th power, you should get 81. Please, 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 please keep in mind that 3 to the 4th power does not mean 3 times 4. Do not do that math. That is not what an exponent means. That means that we are doing 3 times 3 times 3 times 3. You are multiplying 3 by itself 4 times. For letter B, you're going to notice that you have 2 different bases. Since you have 2 different bases, you're going to need to evaluate each base separately and get the standard form of that number. So please plug in 2 to the 3rd power in your calculator. You should get 8. Plug in 7 squared to your calculator. Most calculators do have a squared button. It does say x squared on it. So if you press 7 and then x squared, it should square it for you, and you should get 49. 8 plus 49 will be your final step, and our answer is 57. Lastly, 1 to the 6th power, that should be an easy one for us. 1 times itself, no matter how many times, is always going to be 1. Again, when you are evaluating this, I cannot stress to you enough how important it is for you to remember that exponents mean repeated multiplication of that base. The number one mistake that people make when solving exponential problems is that they multiply the base and the exponent. I can't make that any more simpler, that's the number one mistake. Don't do it, okay? Our next little topic here is that negative bases must be written in parentheses. I did start to tell you this earlier because I wanted to highlight to you that that was extremely important, and now I'm going to show you why, okay? Even though the 2 problems that you see look similar, they do not mean the same thing. The first problem means that we are going to take -3 times -3 times -3 times -3. When you use -3 as your base, and tell your calculator that you are using -3 as your base, and you think about the rule that I taught you about counting your negatives, you're going to see that our answer should be positive. So we should end up with an 81 as our answer, positive 81. If you do not put those parentheses into there, what your calculator is going to do is it's going to say, okay, the base is 3. Directly, the number that's directly in front of the exponent is what the base is. So if you do not have a parenthesis in there, you are not including the negative in the base. So technically, what this means is that we have a -1 times 3 times 3 times 3 times 3 because we don't have a parenthesis. So then we would be saying -1 times 81, which gives us a -81. This is the behind the scenes math that is going on in there. So when you plug this into your calculator, this is what your calculator is thinking. It is saying, okay, my base is 3. I'm going to go ahead and evaluate that and get 81 and then multiply it by a -1 and give you an answer of -81. As you can see, they are not the same. You have to make sure that if your base is negative, you include those parentheses, or else your calculator will interpret that problem wrong. If you have questions about that concept, please let me know. It is extremely important in order for you to accurately complete these problems. At this point, I am going to stop this recording so that we do not time out, and I will pick up with part 2 of this lesson in a separate recording. Thank you.